It's interesting what you say.
Yeah, I have to do another collage, a bigger one. I have to do a 3-page paper on that.
All right, welcome everyone. So our exam will become available after class today and be available until the start of class on Thursday, right? Because there's normally no class on Tuesdays. We will not be having a class meeting on Wednesday. You are welcome to use that time to either take the exam or study for the exam, depending on what works best for your schedule. Are there any questions about the logistics for the exam? Sandra?
I just wish it was on Friday.
My sympathies.
Yeah.
I tried to set up the exam so that each exam was like right after a sort of significant chapter break. So this one comes right after the end of chapter 7. And this is what it ended up being. But you can choose whether you want to take it after class today or Tuesday or Wednesday or on Thursday morning. Sarah.
You're gonna be posting the pre-class assignments for.
Yes, I wrote them over the weekend and then realized that I didn't actually put them into the module. They're in the module now so that we can see them. Sorry about that.
Yeah, she had all done by
Stop.
All right. So what questions do you have about either the practice exam or the extra practice problems? Betty.
Homework 19, problem 7A.
Homework 19, problem 7A.
Oh, yeah. No, I entered it.
All right. So this is Jocko's garage. And we have data on 10 different cars with values of what Jocko's garage estimate is for the repair and a competing garage. And I believe in the previous problem, you established that a paired t-test is going to be appropriate because the differences are approximately normally distributed, even though the values for Jocko's garage and the competing garage are not normally distributed and the sample sizes are small. So here, we want to use a paired t-test. So our strategy for doing a paired t-test is first find the differences. So like Jocko's minus the competing garage, and then use a one sample t-test. So there are a couple of different ways you can do this. One approach is to get the data into your lists on your calculator. So stat edit. And then you could just compute the differences by hand or using your calculator and put them into list 1. Sandra, are you looking up a web work problem? And then do the paired t-test on that. If you want, you can actually use the lists to compute the differences. So you could put Jocko's in L1 and the competing garage in L2. And then use your arrow keys to highlight the top of L3, like where it says L3. And then you can type in a formula. So you can type in L1 minus L2. And that will automatically fill in your third list with the differences between list 1 and list 2. And then you would go to stat tests and t-test, because we want the one sample t-test. And you do input equals data. And when it asks you for the list, put in list L3, or whichever list it is that contains the differences. Another thing to pay attention to here is we want to test whether Jocko's Garage is setting unreasonably high cost estimates. So in other words, our null hypothesis will be that the mean difference is equal to 0. Our alternative hypothesis will be that the mean difference is greater than 0, assuming that you did the subtraction in the order Jocko's minus the competing garage. So that will affect your p-value as well. Nettie, does that answer your question?
Yeah.
All right. Other questions about homework or practice exam or extra practice problems? Mike,
I think it was like 5D part 2.
on the homework
No, on the practice.
practice exam. All right, so this was whether balsa wood has different elasticity when it is wet compared to when it is dry. And 5D, part 2, was if we found a 95% confidence interval for the difference of the mean elasticity when wet minus the mean elasticity when it's dry, would it contain 0? So this is asking about the connection between confidence intervals and hypothesis tests. So up here, in 5C, let's see, where was we're testing whether it has a different elasticity when wet compared to dry. So our null hypothesis is that mu wet minus mu dry equals 0. And the alternative hypothesis is going to be two-sided. We're interested in a difference in either direction from 0, either if it's positive or if it's negative. So then in 5C, we find the proportion of simulations with the sample mean for wet minus the sample mean for dry greater than different values. And based on this, we can talk about this if people have questions about it. You end up with a p-value of 0.001. 0.003. So that's a, Sarah.
Can you talk about that?
Yeah, so this is saying, this might be easier to draw. Yeah,
Well, it's like it's in order somehow. You can help with your question.
so if you think about what the null distribution in the applet would look like, so this would be the multiple means applet. This is telling us that if we go to negative 4.159, the proportion of simulations greater than that is 0.999. If we go to 0, the proportion of simulations greater than that is 0.482. And if we go to positive 4.159, yeah, 0.002 of the simulations are greater than that. So then, think about what do we want to compute in order to get the p-values. So our test statistic ends up being positive or negative 2. Wet minus dry, negative 4.159. So our observed value of the difference of sample means in the sample was negative 4.159. So the p-value is going to be the proportion of simulations that are at least as extreme as that. But we said that our alternative hypothesis was two-sided. So what counts as at least as extreme as negative 4.159? Sarah?
So like either side.
Right.
Beyond, I guess.
Yeah, so in the applet, it would be beyond negative 1.4 or negative 4.159. So what that means in practice is less than or equal to negative 4.159 or greater than or equal to positive 4.159. So then the goal is to find what proportion is in that region, these two tails, using the data that we got from the table. Well, the table told us that the proportion greater than or equal to 4.159 was 0.002. And then it told us that the proportion greater than or equal to negative 4.159 was 0.999. So what proportion is less than negative 4.159? No, got a yes? Yeah, how'd you get that? Exactly, that's the complement rule. So that's 0.001. So that's 0.001. So then the total proportion in the tails is the sum of those two. So 0.001 plus 0.002 gives us a p-value of 0.00. Questions about this part? All right. So now that we have the p-value, we can come down to 5D part 2. And so now we can say we got a p-value of 0.003. What does that tell us about the 95% confidence interval? Talk this over with your table.
So we would not. No, we talked about the worksheet. Yeah. So yeah, so it's so small. And the null is equal to 0. So we're trying to 0 is the 90%.
As long as it's below 0.1, still make the null, make it
I'm
0.
not sure like where.
I don't think it matters.
As long as it's the null, 0.
So the confidence.
If the null.
Or the confidence.
Maybe is it-
Remember the confidence interval value is
Confidence interval matters. 0.05 to p-value. 99% confidence interval.
And then this would be yes.
So as long as you reject the null, the null equals 0.
So it depends on the system.
Yeah.
Just determine if you reject the null, then 0.
All right. So 95% confidence interval. What level of significance does that correspond to? Nettie? 0.05, right. So we're taking 100% minus the level of confidence. So we got 5%. And then turn that into a decimal by dividing it by 100. So then at a 0.05 level of significance, are we rejecting a null hypothesis? Yeah. At a 0.05 level of significance, we reject the null hypothesis because our p-value was 0.003, which is less than 0.05. So that's saying our null hypothesis was that mu wet minus mu dry equaled 0. So that this is saying that 0 is not a plausible value for mu wet minus mu dry. And the confidence interval is the interval of values that we consider plausible for the parameter. So if the confidence interval is the interval of plausible values and 0 is not plausible, then 0 can't be in the confidence interval. Mine, does that answer your question?
Yes, it does.
Cool. Other questions about the practice exam, extra practice problems, or homework? Here's our 5B. Yeah. So this one. All right. So here was our sort of summary of the data. The center of the distribution of the shuffled differences in means is most likely close to what value? So the key idea here is this graph of the shuffled differences in means is representing the null distribution. It's representing what we expect if the null hypothesis is true. And our null hypothesis was that mu wet minus mu dry equals 0. So we expect this to be centered near 0. Oh, questions that people have. Nutty.
It's one of the like Canvas does this question from.
Yep.
I just get confused when to do a one sample versus a two sample.
Good question. So you're right to be thinking t-test here because we're looking at how much exercise people get per day. So if we sort of had a data set before we summarize the data, we'd have like person 1, 2, 3, ... And then we'd be recording minutes of exercise. So like 30, 60, 0, ... So our variable here is a quantitative variable, minutes of exercise. And then we want to look at what we're comparing. So here, we want to know if college students get a different amount of exercise. So we've surveyed a random sample of 100 college students. Great. So we know we have a sample of college students. And then we're comparing that to American adults who, according to the CDC, get an average of 17 minutes of exercise per day. We weren't told a sample size for that. So that means that we are going to go ahead and treat that as not coming from a sample, but it's sort of a baseline fact about the population. So that means that we'd be comparing the mean for college students. Is that equal to 17, or is it different? So we're comparing to a specific numerical value that's a fact about a population, not comparing two different samples to see if the population means are different. So that makes this a one sample t-test. Does that answer your question? All right. Other questions that people have? Hi.
For number 16, I'm just wondering why one of the answers. Possible.
This one? So in general, we consider the alternative hypothesis to always be plausible, because it's always believable that there could be some tiny difference between the two groups. And if we had a big enough sample size, then we would be able to tell that they're different. So the alternative hypothesis being plausible is not really something that would depend on the p-value, or that would be an interpretation of the p-value. Does that make sense? questions that people have? Here's a. On homework 19? Yeah. All right, so this is, do husbands tend to be older than their wives? So part E is asking us to define what the p-value is in the context of this problem. So what is the sort of generic definition of a p-value? Tell the people at your table, what's the generic definition of a p-value? All right, Tirza, can you summarize that for us? So just thinking generically, like think back to chapter 1 or back in your notes from chapter 1. Can someone help Tirza out? What's our general definition of a p-value? Mary?
At least as extreme as what you observe in the
Mm-hmm.
assuming the limit.
Right. Yeah, so let's fill in those pieces thinking about this problem. So the first box is the probability of getting something. Is it a difference of the means or a mean of the differences? So here we decided to use a matched pairs study, meaning that within each couple, we're looking at the difference in ages between the husband and the wife, and then taking the average across all the couples. So which statistic are we looking at in this data set? So let's see, raise your hand for a difference of the means. Raise your hand for a mean of the differences. Yeah, we first take the differences within each pair and then take the mean of those. So our statistic is a mean of the differences. And we said that we're computing our statistic in the sample. So the probability of getting a mean of the differences in the sample that's greater than or equal to blank. So this blank is going to be the value from the data. Do you want to look at how to get that?
Yeah, that's.
Sounds good. Let's look at that. So pasting in the marriage ages data. And then we can get the statistic from the sample in two different places in this applet. We have the observed average difference is 1.88 here. We can actually get it in slightly more accurate results up here in the upper right-hand corner of the differences graph. We get the mean out to 3 decimal places in this case. So that's our value that we observe in the sample. So greater than or equal to 1.875. And then the p-value is computed assuming that the null hypothesis is true. What's the null hypothesis in this problem? Nettie? Yeah, that the mean of the differences, so mu sub d, is 0. Does that answer your question, Teresa?
Yeah, I was putting the data in that, but you know, it wasn't specific enough. I didn't know that.
Yeah. Up in that corner. Oh. Other questions that people have? Nettie?
For problem 19, I'm wondering how we know it's 60 to 30% because this people was in.
It's because this is a confidence interval for a difference of proportions. So if it's a difference of proportions, then it's always dealing with the proportion of people or the percentage of people. Does that answer your question? Other questions that people have? Questions about past homeworks or past in-class activities that you'd like to get cleared up? Mine.
For the parity test, we use the 1 single t test and we use algorithm. Like if they were to give us like data.
Right, yep, so to do a paired t-test on your calculator, you're using a 1 sample t-test on the differences. So yeah, you can either compute the differences like by hand and then put them into whatever list you want. Or if you're doing the raw data in L1 and L2, and then having your calculator compute L1 minus L2 and put that in L3, then you'd be doing the t-test on list L3. Other questions that people have? All right, we have about 15 minutes left. So if you feel comfortable, ready to go, you can head out. I will stick around and answer individual questions as we have time.